Hi everyone. Today in this video we are going to use collision theory to explain how catalysts will affect the rate of reaction. And catalyst is different from other factors because it does not increase the frequency of particle collision, but it affects the second point here, which is the activation energy. So just a recap, particles must collide with sufficient energy, and this energy is known as activation energy for a chemical reaction to happen. Let's look at this diagram. This is an energy level diagram with activation energy. As you can see from the diagram, the presence of catalyst provides an alternate path for the chemical reaction to happen. In other words, catalyst lowers down the activation energy that enables the chemical reaction to happen easier. So we say positive catalyst lowers down the activation energy. More colliding particles are able to overcome the lower activation energy, resulting the increase in successful collision. Notice the presence of catalyst does not increase the frequency of collision, but lowers down the activation energy. So to investigate the presence of catalysts and how it affects the rate of reaction, we use this chemical reaction, the decomposition of hydrogen peroxide catalyzed by manganese 4 oxide. And in this reaction, hydrogen peroxide will decompose to water and oxygen, and we can collect the oxygen to measure the rate of reaction. So we have two sets. In this experiment, we use two sets, one with small amount of catalyst, second with a large amount of catalyst. Without catalyst, this reaction will happen very slowly to the point we cannot see it happening. So we have two graphs. For the first experiment with small amount of catalyst, we should expect the rate of reaction to be lower. So this curve will represent experiment 1 because of the less steep gradient, and experiment 2 will be the other curve. We can also use another chemical reaction to investigate the effect of catalysts on rate of reaction. We use zinc metal with hydrochloric acid catalyzed by copper 2 sulfate, and in this experiment we are going to collect hydrogen gas to measure the rate of reaction. And we have two sets of experiment, one without catalyst and another one with the copper 2 sulfate catalyst. And we can expect the experiment with catalyst will show a steeper gradient, and this is how we conduct experiments to investigate how catalysts will affect the rate of reaction. And just before I end, I would like to emphasize on this graph one more time. This horizontal line shows that the rate of reaction is 0. That means the reaction is completed at this point. So using this line, we can trace the maximum amount of gas produced. And from the gas produced, we can trace backwards to find out how much zinc is used and how much hydrochloric acid is used. And that's all for this lesson on catalysts.